This is Mrs. Peck showing you how to fill in page 6 in your notes for Unit 11. Here we're looking at how molecules that can be as big as organic molecules, that for those molecules you might need more information in a name and in a formula than just what we have established so far. So, for example, for butanes, which have a formula of C4H10, our first idea would be put all the carbons in the middle, connect them to each other with a single bond, because you know it's an ane, so only single bonds, belongs to the alkane series. And then you would make 4 bonds around each carbon. Some of these bonds already connect the carbon to another carbon. That's what you have here in the middle. And the remaining bonds around each carbon would be connected to a hydrogen up to the number 10, which really fills up all the spaces. But with having so many carbons, who or what tells you that all the carbons are in a row? Technically, you could have a branch from the middle carbon and still have 4 carbons total. If you then, again, provide hydrogen on each of the remaining bonds that each carbon has to make, that's 4. Then we still get the same total number as we had before. We still get 10 hydrogen atoms. But these 2 molecules clearly look different, and those chemicals that have these molecules in them react slightly different. So that different structure does make a difference in the actual substance. And as a result of that, we need to be able to distinguish, if we take out a bottle of our storage room, which of the 2 are we working with. That said, if you have this substance with all the carbons in one straight line, we call it N and then just the name that we would expect. This is a butane, N for normal, which means that all carbons are in one continuous line. The second example does not have all the carbons in one continuous line. Our continuous line of carbons only has 3 carbons in a row, and then we have a branch. So we first name the 3 carbons, which gives us the prefix prop as per table P. We still have only single bonds between the carbons, which means we have the ending ane, just like we had it over here. But now we have to say, well, we don't just have a propane, we have a propane with a branch on that second carbon, on that middle carbon. So the second carbon here in the middle is connected to a branch, and the branch in this case has 1 carbon. So the 1 carbon gives us the prefix meth. The fact that this is on carbon number 2 gives us the 2, and the YL indicates it is a branch. So that's why this is called 2-methylpropane. Good. Below this, you have a list of rules to help you name a formula that shows you the structural formula. Name such a molecule where you have the structural formula given, not just the molecular formula. So let's have a closer look at that with an example. So first you have to identify the main chain. If you have a molecule with a double or triple bond or any other special feature, that is automatically the main chain. If there is no such special feature, you choose the longest continuing carbon chain. So in the example below, here in the first example, we have a continuous carbon chain of 4 carbons across. We also have a continuous carbon chain if you go this way, and we have another continuous carbon chain if you go this way. Now, out of those, the red and the green one both consist of 4 carbons. So we can choose either one of those as the main chain. The blue one only has 3 carbons, so that cannot be the main chain. Good. So we identified our main chain, and just for ease, it's usually easier if we go across. And as we have that option for the main chain, I'm going to use the chain going across as my main chain. Good. So we have identified the main chain, and so now we need to name it. With 4 carbons in a row, we will use the prefix but. Your main chain is always named at the end of your name. So I leave a little space here. And we have 4 carbons. They're all single bonded, so it's going to be a butane. So far, so good. So we're done with this here. Then we have to number all carbon atoms in that main chain from both sides. So the first one, second, third, fourth. We could also number it 1, 2, 3, 4 from the other direction. And the next step tells you why we need to do that. It says, look at the branches hanging off. So here's our branch. And indicate the position of the branch by the lowest possible number for this carbon atom. So this branch is attached to this carbon here, and depending on which direction we're counting by, that would either be counting as carbon number 3 if you go from left to right, or carbon number 2 if you go from right to left. Now, in real life, molecules are consistently like swirling around and moving, so the direction really doesn't matter. But we should have a uniform system of naming those, because if one person talks of the molecule with carbon 3 having the branch, and the other person talks of the molecule with carbon 2 having the branch, and you might not realize that you're talking about the same thing, then that can cause problems. Good. So in order to simplify that, we are always choosing the lowest number. So in this case, we would not choose the number 3, we would choose the number 2, and by doing that, the top set of numbers becomes chosen. So once you have that choice, you made that choice to get the lower number, you stick with that choice over the whole molecule. Good. So now we know where the branch is, and we know that it has only 1 carbon. The location is given with the number, so that number 2 becomes the location of the branch, and the branch length is 1 carbon, so that means it's a meth, and because it's a branch, it gets the YL ending, so we have a 2-methyl butane here. So we did this, we chose the lower number, and we named the branches. We did not have to worry about step F because there's only 1 branch there. Let's look at the next example. We have 3 carbons across, 3 carbons if you go up, 3 carbons if you go from the top down, 3 carbons if you go around any corner. So that means we have as our longest chain a chain of 3 carbons. That means 3 carbons indicate prop. All carbons are single bonded, so it is a propane. Now in this case, if we take the one across as our main chain, we have carbon 1, 2, 3. The branch here is at the middle carbon, so even if I count 1, 2, 3 from the other direction, it's always going to be at carbon 2. We have 2 branches of this. a 1-carbon branch up and a 1-carbon branch down. Now we have to look at this last piece of information. It says if there's more than one branch, write a number for each branch, a location for each branch. And if you have the same branch type more than once, you indicate that with the prefixes di, tri, tetra, and so on, to indicate how many of each branch type you have. So here we have 2 branches. They're both coming out of carbon number 2, and they're both branches with just 1 carbon. So they're both coming out of the same location, but each branch needs its own number. So we're going to write the same number twice. Each branch is a methyl branch because each branch only has 1 carbon. But because there are 2 of them, we're going to call this now a dimethyl. So we have 2,2 dimethyl propane.